the purpose of this video is to help you refresh your memory about returns to scale, which is a quite important economic concept. As said previously, these you should already learn this from the introductory course or intermediate microeconomics, and but because we're gonna use that in this course, so I think it's better for us to kind of go over this one more time. Okay, now I'm gonna give you 3 different production functions. Okay, and the first one, I believe this is the simplest linear production function, which we actually used before, right? Now here in this function we see K as capital and L as labor. Okay, and we're gonna start with the more general form here. So the initial level of capital is K1 and the initial level of labor is L1. Okay, so K1 and L1 could be any amount. Okay, and for example, K1 could be 10, L1 could be 100, or K1 could be 20, L1 could be 50. Okay, whatever number you want to use. So now what we would do is we plug in the numbers to our production function. Okay, so under these with the K1 units of capital and L1 units of labor, we believe we can produce Y1 units of output. Okay, so that's going to be K1 plus L1. Alright, now as discussed in the previous video, when we talk about the returns to scale, we're going to change the scale, right? The scale of inputs, and then we're going to see how the scale of output changes. Now here, just to be simpler, let's simply double the size or the amount of capital and labor. Okay, so by that we're saying that now K equals 2K1. Alright, so for example, the firm used to have 10 units of capital, like 10 assembly lines. Now it gets 20. Okay, so it doubles, and then the labor doubles as well. Okay, so here when we talk about the change in scale, we have to change all factors instead of just one. Okay, we have to change all factors of production by the same percentage point. Okay, the same amount. So here what we will do is we're going to look at the new level of output. Okay, again we just plug these 2K1 and 2L1 back into the production function. Okay, the function itself stays the same, right? But what has been changed is just the units, okay, the amount of capital and labor. So here it's gonna be 2K1 plus 2L1. Alright, now here we just do a little bit of math trick. Now we take the constant 2 out of the parentheses, so it's going to be 2 times K1 plus L1. Alright, the reason we want to make this mathematical transformation is, if you look closely, what's in the parentheses, K1 plus L1, this is exactly Y1, the original level of output, right? So this means it equals 2Y1. Alright, now don't forget the left hand side of the equation is Y2, the new level of output. So what we find here is when we double the size of capital and labor, the size of output doubles as a result. Okay, so this is so-called constant returns to scale. Alright? So the returns to the inputs or the scale doesn't change. Okay? And if we use 100% more capital and labor, we're going to get 100% more output. Alright? I think that's straightforward. Now let's take a look at the second case. The second case, as you can find here, it's non-linear. Okay, so y, the output, equals K times L. Okay, the product of capital and labor. As what we did before, the first thing we're gonna do is to plug in the numbers. Okay, I'm sorry, to plug in these specific levels to the production function. So the initial level of output y1 equals K1 times L1. Alright? Now we're going to try the same thing. We're going to double the amount of machinery, equipment, tools, and the amount of workers. Okay? Now the new level of output would be y2, right? And we just plug these levels back into the production function. So it's going to be 2k1 times 2l1. Alright? Again, like before, we're going to take the numbers or the constants out to the front. So it's going to be 2 times 2, okay, this one here and this one here, and times K1 times L1. Alright, so this equals 4K1 L1. Alright, once again here, K1 times L1, go back to the original level. That gives us the y1. That's exactly how much the firm produced before, right? Before we changed the amount of capital and labor. So this equals 4y1, right? This equals 4y1. Remember, on the left hand side it's y2. Okay, that's a new level of output. Now here what we find is when we double the amount of capital and labor, we end up with 4 times more output. Okay, so in other words, the output is more than doubled. Okay, it's more than 2y1. This is so-called increasing returns to scale. Okay, increasing returns to scale. All right. So when you change the capital and labor for a certain amount or a certain percentage, you find that the output would be changed more than that percentage point. Okay. All right. Now the third example here, it's also non-linear. So the output equals K over L, okay, or K divided by L. Alright, so the initial level of output would be K1 over L1, okay, and then we're gonna double the amount of capital and labor. Okay, let's say what's gonna happen to our output y2, right? This equals, again, plug the specific levels back into the production function, 2k1 over 2l1. Here we find the number 2 here would be cancelled out. Okay, so what's left over here is just k1 over l1. Alright, and we notice that k1 over l1 is just y1, right? and on the left hand side that's y2. Alright, so here what we find is when we double the amount of capital and labor, the output stays the same. Okay, in other words, it's definitely not doubled, okay, or less than doubled. This is so-called decreasing returns to scale. Okay, so for the returns to scale, there are only three possibilities: constant returns to scale, increasing returns to scale, or decreasing returns to scale. Okay, now two more things I want to mention here. Number one, you notice that every time when we change the amount of capital and labor, we always said we double them, right? If you want to triple them, if you want to go with any other percentage change, that's totally fine. Okay, if you said I want to make the math more challenging, I want to do like 50% increase or 125% increase, that's fine. Okay, you're going to reach the same conclusion. All right, you can try that. You can make some questions on your own and try it. Okay, here what I demonstrated is just double these inputs and see if the output is doubled. Okay, of course if you try tripled, then triple the inputs, then you have to check if the output would be tripled as a result. Okay, and so that's one thing. The next thing, which is even more important, is I want you guys to think about the economic intuition. Okay, as we said before, the math is just the tool, okay, to help us understand the economic insights, right? So here I do want you guys to think about the economic intuition of these returns to scale. Okay, probably the constant returns to scale is pretty easy to understand, right? Because we double the amount of machinery, equipment, and workers. Of course, we should expect our output would be doubled, right? So that might be, kind of what the common sense tells us. But what we're trying to say about the increasing or decreasing returns to scale. Put it differently, what kind of the real world situation we're trying to describe or mimic with these two types of returns to scale? Okay, when we mention increasing returns to scale, what kind of situation we're looking at in the real world? And the same thing for decreasing returns to scale. So during our virtual meeting, we're gonna share our thoughts about this. We're gonna discuss about this, okay, more in depth.